Hi. So as for this problem which we see that there's a buoy that's there in a ocean, in a river. So buoys are basically those objects which are used to uh, gather information about the temperature, the climate in that particular place, the current flow, the salinity, and other such informations. Well, these are deployed in various parts across rivers, oceans, seas, and everything else. Okay, so let this be the direction of the flow of the river, and of the velocity of the river be vr. So away from this buoy we have two boats which are moving, one in the direction of the river, so let the velocity of the boat be v, and another one, and this particular boat is a, and another one in the direction perpendicular to the direction of the river. So let the velocity of this be same, which is VB, and the boat here is B. So we have been asked to calculate the time that it takes for both the boats to reach a distance x away from the buoy. So let this be the point here, and this, since the velocity of the river would be acting in the horizontal direction, let this be the point x. Okay, let this be the point P, and this is the point P for PA, and PB for the boat P. So the distance here is x, and similarly the distance here is x. So we have to calculate the ratio of the time it takes for boat A to go to x, point A, travel distance of x to point A and come back. Similarly for point B. So let's take it, this is boat A and this is boat B. So there's one more information which says that the velocity of the boat with respect to the water is 1.2 times greater than the velocity of the river. So this would be roughly equal to 1.2 times the velocity of the river. Okay. So for A to reach a point X, so let this be the origin. Oh, okay. So for A we have to correct 0 to PA and PA to 0. Oh. Okay. So the time it takes for 0 to PA would be the distance traveled Vx by the velocity would be getting added to the velocity of the boat. So because it's in the direction of the velocity of the river, so divided by Vb plus Vr. Same way for here it would be x by velocity of boat minus Vr. Okay. So if I have to add them, so I'll do that part at a later point in time. For B, it would be reaching from O to PB and from PB back to O. So for the boat B to reach from O to PB, it's acting across, so it's moving in this direction, but it will definitely end up in this direction because of the velocity of the river. So this would be Vb and this is Vr. So the resultant velocity for in this particular case would be root over Vb square minus Vr square. So the time taken from O to Pb would be x by root over Vb square minus Vr square. Similarly from PB to O it's the same, so it just has it has moved in a perpendicular direction. Here also it would have to go back in the same direction, so the velocity remains the same, root over Vb square minus Vr square. Okay, so it's now we have to get the times, the time ratio of the times taken by A and B. So in this case TA will be equal to x by Vb plus Vr plus x by Vb minus Vr. Same way Tb is equal to x by root over Vb square minus Vr square, and 2 times the same time it has taken, so 2x by Vb square minus Vr square. So if I have to calculate the ratio of the times, so it will be Ta by Tb, I'll be getting If I take x as a common factor, x into 1 by Vb my plus Vr plus 1 by Vb minus Vr divided by 2x by root Vb square minus Vr square. So this is the equation which I set up. So technically speaking, my work ends here after setting up of this equation. I can either do it by substituting Vb equal to 1.2 Vr or without substitution. So without substitution would be a bit easier. So let's take that approach. So since it's the denominator here, so this x and this x get cancelled. So what we are now, if we do solve the numerator, so what we get is cross multiplication of these two. So it's Vb minus Vr plus Vr plus Vb. So Vr gets cancelled out, divided by Vb square minus Vr square. Okay, so this divided by, so x we are cancelled, what we are left with is 2 into root over Vb square minus Vr square. Okay, so this would lead to let me do it, 2Vb by Vb square minus Vr square big by 2 by root over Vb square minus Vr square. So this 2 and this 2 gets cancelled. So this particular term is nothing but the square of this term. So I would just cancel this and have a square root here, so that my life gets easier. So now for more space, so once I come down, so all I need to do is Ta by Tb will be equal to Vb by, so now I substitute Vb equal to 1.2 Vr, which we have got it, which was given in the equation. So 1.2 Vr square, Vr whole square minus Vr square. Oops, I did not substitute this particular term, which I'll do in the next term. So this is 1.2 Vr by 1.2 into 1.2 would be 1.44 Vr square minus Vr square. So the square root still stays. So that would be equal to, I can get the Vr outside. So substitution of these two would be 1.2 Vr by Vr into 0.44 square root. So these two get cancelled out. Now all I'll be left with is 1.2 by, since the Vr is cancelled out here, I have 0.44 square root, which is about 0.66. So it's approximately equal to 1.8. So the ratio of the times taken by the boats would be 1.8. So that means the time taken by boat A to go forward and come back would be 1.8 times more than the time taken by the boat B to go across and come back to the same point.